So in this video, we're going to talk about compound interest word problems. So for example, we have this problem. Joel invested 215,000 pesos in a saving account that pays an annual interest rate of 5%. The savings account is set to compound quarterly. How much is in Joel's account after 5 years? All right, so let's understand this problem. So Joel is investing 215,000 in his account, and there is an annual interest rate. So if you say annual, that's yearly or every year rate of 5%. So that means it will increase by 5% every year. But it's saying also that the savings account is set to compound quarterly. So it will be compounded quarterly. How much is in Joel's account after 5 years? So it's kind of different, unlike the simple interest where you will just compute whatever is the yearly interest rate and then multiply it by 5 years and then add it to the invested amount, because this is compounded quarterly. So that means it will generate interest 4 times in a year. So it's quarterly. So that means it's every three months, because 12 months divided by 4 is 3. So how do we compute this? So we're after of the amount, the end amount, which is after 5 years. So we name it A equals, and then so A, or the amount, the end amount, or the final amount, is computed in this formula P, which is the principal amount, which is the one invested, times 1 plus the 1 is always 1, it's constant, it's already part of the formula, plus R is the rate, over N is the compound, how many times it is being compounded. Is it quarterly? If it's quarterly, then it's 4 times every year, so it's 4. If it's semi-annually, so that means it's twice a year, so it's N is 2, and so on. So N, so R divided by N, again R is the rate, interest rate, to the power of N times T. So there are two N's here, it's the same N in the denominator, so same value in the exponent. So N times T. T is the time, which is the 5 years. So that the T is in years usually. So if the given is months, so you have to write it in fractions. So anyway, let's compute this problem. So we're going to substitute everything, whatever is in the given. So let's just copy A equals, and then P, or the invested amount, is 215,000. So that's the principal amount, and then times. So we're going to put the parentheses in 1 plus the R is the, again, interest rate. The annual interest rate is 5%, but you can't put there 5%. You have to convert it into decimal. So how do you change it into decimal? You just divide that value by 100. So you can just use your calculator. 5 divided by 100. So it will change to 0.05. That is the equivalent decimal form of the percent, 5%. So just simply divide a percent into by 100, 5 divided by 100, to convert it into decimal. So it's important to write it in decimal first. Convert it into decimal first before you start computing. So anyway, I already put there the decimal form, 0.05, and then over N. So the N is, it says compounded quarterly. So divided by 4. So because quarter means 4, that means 4 times every year. And then the exponent, N times T, so N again is 4. And then times T, T is the 5 years. So again, the T is in years. So if the given is, let's say 3 months, so you're going to put there 3 over 12, because you don't put 3 because, again, T is in years. All right, so Um, we're gonna start solving now. Copy the a equals and then let's copy again the 215,000 because we're gonna compute the one inside. Um, within the parentheses and also the exponent based on the PEMDAS. So we compute first parentheses, exponent, multiplication or division, addition or subtraction. So we have 1 plus and then compute 0.05 divided by 4, that is 0.0125. And then you can also compute the top 4 times 5, which is 20. I mean the exponent. So you can just do it simultaneously, the fraction and the exponent, and it will not affect the value. But you can compute it separately, although it's longer. So, and then we are going to copy again 215,000 because we're going to compute the one inside the parentheses first. 1 plus 0.0125, so it will be 1.0125. Then copy the exponent 20. So let's compute this now. This is approximately, so it's just, I'm using approximately equal to because we're going to round off the value, so it's not anymore the exact value, but we just round it off because we're going to compute. Let's copy the 215,000 and calculate. You can use the calculator. 1.0125 to the power of 20. You input that in the calculator, and then you're gonna get a value. It's a long answer probably, but we can just round it up to 2 decimal places. So approximately equal to 1.28. That's why we are using approximately equal to. So that's the wiggly equal sign. That's approximately equal to. And then we multiply 215,000 times 1.28. So you will get a value of 275,200 pesos. So the end of 5 years, Joel will have 275,200. All right, so let's have another problem. So we have Matt is planning to buy a car in 3 years. He wants to invest 200,000 now and hopes to have 350,000 to spend on the car when he buys it. So what kind of interest rate would he need if his investment is compounded monthly? So this problem is it's totally different from the previous one because it's looking for the interest rate and the amount and the principal amount, the final amount and the principal amount is given. So the situation is Matt wants to buy a car after 3 years, but he has only 200,000 and he wants to have to make it 350,000 at the end of 3 years. So it's kind of a big amount after 3 years, so it should be a high, very high interest rate. And what should be the interest rate, which is compounded monthly, to get that 350,000 at the end of 3 years? So we use this formula. This is actually derived from the previous formula, but I will not show anymore how it is being derived. But it's R equals N. N is the compounded, how many times it's being compounded every year. So it's monthly. So that means it's 12 times uh, every year. So that means N should be 12. So anyway, N times T to root N T root O and A over P. So what's NT root? It's like square root if it's 2, cube root if it's 3, but since the number is NT, so we don't know yet the name, we'll just name it NT root. Um, A over P. So A is the final amount and the P is the principal amount minus 1. So minus 1 is always minus 1, but it's not inside the square. I mean the root or the radical sign. So let us compute this now. I mean, we'll just substitute everything with this given. So R equals, so N is compounded monthly. So if it's monthly, that means it's 12 times in a year. And then N times T, so N is 12, time is 3 years. And then the radical sign, the root or the radical sign. So, and then the A is the final amount, which is 350,000. And then the bottom is the invested amount, principal amount, which is 200,000. And then the minus one. So it's important that the minus one should be not inside the radical sign, or else it will give you a wrong value. So you have to be careful in putting it in the calculator. So, all right. Now let's compute the one inside the parentheses first. So we have the index of the radical sign, which is 12 times 3. That's 36. So it's 36 root. It's like the fifth root, but in this case it's 36. It's 36 root of 1.75. So where do we get 1.75? That is the quotient of 350,000 divided by 200,000. So that's 1.75. And then copy the minus 1. So again, we get 36 from 12 times 3. We get 1.75 from the one inside the radical sign, 350,000 divided by 200,000. Now I'm going to compute the 36th root of 1.75. So we'll just put here R approximately equal to, because we're going to round off later. So it will not be exact anymore. So we'll just use like approximately equal to, and then copy the 12. And then what's the value of 36th root of 1.75, which is approximately 1.02. So we'll just round it off to 2 decimal places. And then copy the minus 1. So again, we get 1.02 from 36th root of 1.75. Then compute the one inside the parenthesis, 1.02 minus 1. We'll just copy the R approximately equal to, and then 1.02 minus 1 is 0.02. And then copy the 12. Then compute or multiply 12 times 0.02. So which is 0.24. Of course, this is just an approximation because we round it off in 1.02. So what is 0.24? So to convert it into percent, so how do we do that? We multiply it by 100 to get the percent. This is in this decimal form. So 0.24 times 100 is 24%. So that means for him to get that 350,000 final amount at the end of 3 years, he has to invest it in a bank where it's offering interest rate of a high, very high amount, which is 24% compounded monthly.